In this video, we will focus on approaches to drying elderberry as a means of food preservation, and we'll highlight various food safety considerations. If you haven't already, you may wish to watch the first videos on harvest and post-harvest practices. Drying can be a relatively simple and inexpensive method to extend the shelf life of your elderberries after harvest. The energy needed to dry fruit is typically less than that required for freezing or canning, and dried products often require less storage space than jars and freezer containers. Additionally, since drying, by definition, removes water from the fruit, dried products weigh less and can therefore cost less to transport. Drying is the evaporation of water from food. Usually this happens as a result of heat assisted by air circulation. This is called dehydration. Water can also be removed from food through sublimation, which is when frozen water, i.e. ice, is directly converted to water vapor. This is how freeze drying works. Water activity in foods allows the growth of microorganisms, which can cause toxicity or spoilage. Therefore, removing water from food slows microbial growth and extends its shelf life. Water activity is the amount of free water in food. Free water is water not bound to other solutes, such as salt or sugar, and therefore is available for enzymatic activity or for microbial growth. This is not the same as moisture content. Water activity is measured in values from 0.0 to 1.0. A water activity of 0.85 or below will inhibit the growth of pathogenic bacteria such as Salmonella, Escherichia coli, Listeria monocytogenes, and Staphylococcus aureus. However, if these pathogens are already present in the food, they can survive for extended periods of time, even if water activity is below 0.85. Drying is not considered a kill step, a treatment which drastically reduces harmful levels of pathogens in food. For this reason, it is critical that harvest and post-harvest best management practices are followed in order to minimize the risk of microbial contamination before and during the drying process. Cleaning is a series of steps that are intended to remove soil or debris from surfaces before the application of an approved sanitizer. It is important to understand that the cleaning and sanitation steps are equally essential for minimizing microbial contamination. Standard operation procedures, or SOPs, for cleaning and sanitation of your farm or facility specify what needs to be cleaned and sanitized. Records should be kept detailing specifics of the cleaning and sanitation, including date, person operating, and measurements of chemical concentration for sanitizers. Your chosen sanitizer must have an EPA registration number, be approved for food contact surfaces, be mixed and applied according to the label. There are many different methods for drying elderberries. All drying systems should be made from food contact materials for areas that will come into contact with the product. Examples of food contact materials are stainless steel or food-grade plastic. These are materials that can be appropriately cleaned and sanitized. Avoid screens made from hardware cloth or galvanized metal. This is typically coated with cadmium or zinc, which can oxidize, leaving harmful residues on the food. Also avoid copper and aluminum screening. In general, air circulation is important to the drying process. This is what carries away moisture. For this reason, mesh or other materials that allow good airflow promote faster drying. Now, let's look at a few different drying systems. Sun drying is where the product is dried outdoors, making use of ambient temperatures to dry the product. This drying method is low cost and easily accessible. However, weather can be variable and unpredictable, making this method imprecise. The National Center for Home Food Preservation recommends minimum temperatures of 85 degrees and humidity below 60% for sun drying. Some tips for sun drying include: spread fruit evenly on mesh screen racks. For better airflow, make sure fruit is not more than 1 layer deep. Keeping racks off the ground using table legs or a frame. Protecting the fruit from birds and insects by suspending cheesecloth or light netting over the rack. Placing table legs in containers of water to exclude insects. Like sun drying, solar drying is another form of passive drying. It occurs in an enclosed space, like a hoop house, where the air is heated by solar radiation. Some growers find that drying in a greenhouse can result in excessive exposure to sunlight. A solution may be to install a 50% shade cloth. Electrical dehydrators allow you to have greater control over the temperature. They are available in a variety of sizes, from kitchen to commercial scale. Most dehydrators consist of an enclosed cabinet and forced air circulation. Shallow mesh or perforated trays allow for airflow and uniform air distribution through each tray until the drying process is complete. Freeze drying is a method of water removal that involves dehydration by sublimation under high vacuum pressure. Freeze-dried food products typically possess superior sensory and nutritional qualities when compared with food products dehydrated by other techniques. However, there is a high cost, up to 5 times or more than food dried by other drying techniques. How dry is dry enough? To inhibit the growth of pathogenic bacteria, you need a water activity of 0.85 or below. Dried fruits typically have a water activity range of 0.60 to 0.65. How can you tell the water activity of your dried product? Water activity can be measured using a scientific piece of equipment called a water activity meter. If you do not wish to purchase a water activity meter, you can send a sample to a third-party laboratory to measure water activity for an estimated cost of $15 to $30 per sample. A dry card can be used to get an estimate of water activity. In this method, take a sample of elderberries and place them in an airtight container with a dry card. After 1 hour, the card will give a color response to the relative humidity, which can be used as an indicator to estimate water activity. It is important to note that although the drying process destroys some microbes, foodborne pathogens can survive the drying process and remain inactive but viable until a better environment for growth is encountered. Even dried, elderberries may contain a compound, sambunagrin, which is a cyanogenic glycoside that can cause gastrointestinal disorders. Once the elderberries are dried, they must be stored in proper packaging to maintain their dryness and quality. A good packaging material must be moisture-proof, food-grade, durable, and easy to fill, seal, mark, and store. Store your packaged product in a cool and dark area until it is ready to use, process, or sell. We hope you have enjoyed this series on food safety best practices for elderberry harvest, post-harvest, and drying. For additional information and resources, please visit our website. This series has been brought to you by UC Sustainable Agriculture Research and Education Program, a statewide program of University of California Agriculture and Natural Resources. Thanks for watching.